The wind that sweeps across the peaks of the Rockies today carries a secret, one buried deep beneath the crust of North America. To most, these mountains are nothing more than a breathtaking spine of stone and snow, the continental divide, the postcard perfection of the American West. But to those who study the Earth's restless heart, the Rockies are alive. They move, they breathe, and perhaps they are still growing. 200 million years ago, there were no Rockies, no Colorado skyline, no jagged walls of granite slicing through the clouds. In their place stretched a shallow sea, warm and filled with life, the remains of which still whisper from fossils entombed high above modern valleys. How, then, did those sea creatures end up 8,000 feet in the air? What force could raise the floor of an ocean into the roof of a continent? That is the riddle that has haunted geologists for centuries. A puzzle written not in ink, but in folded layers of rock, in the slow violence of the planet itself. The story begins with a collision. Far below, the surface of our world is split into vast plates that drift upon molten rock, carried by the convecting currents of the Earth's mantle. Where those plates meet, they grind, dive, and crumble, giving birth to mountains, volcanoes, and earthquakes. Every continent bears the scars of those ancient impacts, but few are as dramatic as the Rockies. A chain of peaks stretching over 2,000 miles from British Columbia to New Mexico, and standing as high as 14,000 feet. These mountains are monuments to chaos, and yet, they are also maps of time. Each ridge, each layer of limestone, tells a chapter of the planet's history. The question is not only how they rose, but why now and what comes next. Because even as erosion tears them down, other forces, invisible, relentless, continue to push from below. Beneath the surface, the crust of North America is being pulled, stretched, and lifted by mysterious currents of heat. In places, magma still creeps upward, hinting that the story of the Rockies is not finished. And along a fracture that runs from Colorado to New Mexico, the Rio Grande Rift, the continent itself appears to be splitting in two. Could the same forces that created the Rockies one day destroy them? Could North America, solid, ancient, seemingly eternal, one day be divided by fire? Scientists are beginning to think so. The evidence is scattered across the land like breadcrumbs of a cataclysm yet to come. From fossilized seabeds at the summits of British Columbia to hot springs rich in gases that rise from the mantle, every clue points to a planet still in motion. Some of those clues are millions of years old. Others are bubbling to the surface right now. And the deeper geologists dig, the stranger the story becomes. They find that the Rockies were born not once but twice, first in the north, then again in the south, by entirely different mechanisms. They discover granite that should not exist where it does. They measure forces so vast they could move whole continents. And when they model the slow shifting of the crust, they glimpse a future in which the western half of North America begins to tear away from the east, leaving a sea where the plains once stood. It's an unsettling vision, one that reframes everything we think we know about permanence. Mountains, after all, are supposed to symbolize eternity. They are carved into our myths, our flags, our sense of home. Yet the Rockies tell us the opposite story. Nothing stands still, not even stone. What we call land is, in truth, a restless ocean of rock, surging and collapsing in cycles that last hundreds of millions of years. To see the Rockies is to glimpse one heartbeat of that vast geological pulse, a single upstroke in an endless rhythm of creation and decay. So when we gaze at these mountains, what we are really seeing is motion frozen in time, the thrust of continents colliding, the recoil of erosion clawing them down, the deep breathing of a planet alive beneath our feet. This is the hidden life of the Rockies, a story that spans the birth of North America, the death of ancient seas, and perhaps the coming fracture of the continent itself. From the cold cliffs of Canada to the volcanic deserts of New Mexico, we'll follow the trail of the forces that built, and may yet unbuild, the very bones of our world. Because somewhere beneath these peaks, the Earth is whispering again. And if scientists are right, it's not whispering of the past. It's warning us of the future. Part 1: The First Signs. When the sea became stone. In the northern reaches of British Columbia, where the wind carves through valleys of ancient limestone and the air is thin enough to sting your lungs, lies a place that shouldn't exist. Embedded high on the cliffs of Mount Stephen are the remains of soft-bodied sea creatures, trilobites, spiny worms, and creatures so alien they seem born from another planet. They are fossils from a time when the Rockies did not exist, when this entire region was submerged beneath a warm tropical sea. The discovery was made more than a century ago, but even now it unsettles geologists. How could animals that once lived in the quiet shallows of an ancient ocean end up entombed in rock more than a mile above sea level? The answer, it turns out, begins not in Canada, but in the hidden machinery of the planet itself. 200 million years ago, there was no North America as we know it. The continents were joined together in a single supercontinent called Pangaea. Its coastlines were still being torn apart by immense rifts, invisible seams in the Earth's crust where molten rock pushed upward, splitting the landmass like cracking glass. Over millions of years, the pieces of Pangaea drifted apart, setting the stage for one of the most extraordinary transformations in geological history: the birth of the Rocky Mountains. The process would take tens of millions of years and unfold in two acts, each more violent than the last. The first act began far offshore, where the dense floor of the Pacific Ocean began sliding beneath the lighter crust of the newly forming North American continent. It was a colossal collision, one plate diving beneath another in a process known as subduction. As the Pacific plate was forced downward into the mantle, it dragged entire island chains with it. These ancient volcanic islands, fragments of a broken ocean floor, acted like battering rams. When they reached the edge of the continent, they didn't sink. They crashed. The impact crumpled the seabed like a sheet of paper, shoving the once flat layers of marine sediment thousands of feet upward and hundreds of miles inland. In that violent instant, stretched across geological time, the first foundations of the Rocky Mountains began to rise. The rocks of the Burgess Shale in Yoho National Park tell the story better than any book could. They are a time capsule from 500 million years ago, preserving not only the bones but the soft tissues of creatures that lived long before dinosaurs ever walked the earth. Each fossil is a snapshot of a vanished world. The ocean floor turned into mountain stone. Standing before these cliffs, modern geologists often describe the sensation as vertigo in time. You are standing on what used to be the bottom of the sea, looking out over peaks that once formed the ceiling of the sky. And somewhere between those two extremes, between depth and height, lies the history of every mountain on Earth. But what's most fascinating about the early Rockies is not just that they rose from the sea. It's how they did it. The collision between the Pacific and North American plates didn't simply push the land upward. It folded and fractured it in a series of gigantic thrust faults. Picture a carpet being pushed against a wall. The fabric wrinkles and piles up in folds. That's precisely what happened here. Only the carpet was made of solid rock, and the wall was an entire continent. Over millions of years, those wrinkles hardened into the jagged peaks we now call the Canadian Rockies. The immense forces involved were almost beyond imagination. Layers of limestone and shale several miles thick were sheared and stacked one atop another, with older rocks shoved over younger ones in complete defiance of logic. It was as though the planet itself had decided to rewrite its own chronology. For scientists, the Burgess Shale is not just evidence of the past. It's a clue to a process still unfolding beneath our feet. Even as the Rockies were being uplifted, they were being worn down. Erosion, rain, wind, and ice began to tear at their edges, grinding ancient peaks back into dust. But erosion and uplift are not enemies. They are partners in a delicate balance. As the mountains are stripped of weight from above, their roots, buried deep in the Earth's crust, rise to take their place. The result is a landscape that seems eternal, but is in fact alive, breathing slowly through cycles of creation and decay. Kirk Johnson, a geologist from the Denver Museum of Nature and Science, once described this phenomenon as a planetary traffic accident that never stops. Every few seconds, somewhere on Earth, one piece of crust slides under another, one mountain sinks while another rises. In the grand scheme of things, the Rockies are just the latest scar in an endless chain of collisions that have shaped the surface of our world for billions of years. And yet, something about them remains unique. Unlike the Andes or the Himalayas, which formed along clear tectonic boundaries, the Rockies rise far inland, nearly 1,000 miles from the edge of the Pacific Plate. It's as if the force of the collision traveled far beyond its expected reach, pushing up the land from within. That mystery would puzzle generations of scientists and spark one of the greatest debates in modern geology. Why are the Rockies where they are? Some geologists suggested that a second collision, tens of millions of years later, gave them their final push. Others argued that the Pacific Plate had begun to move differently, not plunging steeply downward but scraping beneath the continent at a shallow angle, transferring its power deep into the interior of North America. Whatever the cause, the result was extraordinary. The flat seabed became folded into 1,000 ridges, and the fossilized remains of ocean life were lifted high into the sky, silent witnesses to the Earth's violent rebirth. Today, those fossils still rest at impossible altitudes, caught in a frozen echo of that ancient upheaval. They remind us that our planet's most majestic creations are born not from stillness, but from collision, from the ceaseless movement of forces far below the surface. When you stand in the shadow of a rocky mountain peak and press your hand to the cold stone, you are touching the remnants of a vanished ocean. And if you listen closely, you might almost hear it, the slow, deep pulse of a world still reshaping itself from within. Part 2: The collision that built a continent. For millions of years after the breakup of Pangaea, the newborn continent of North America drifted westward, sliding slowly across the face of the planet like a vast ship adrift on a molten sea. To the west, the floor of the Pacific Ocean was on the move as well, an enormous conveyor belt of basalt and magma driven by the deep currents of the mantle. Eventually, the two collided, and when they did, the world changed. The Pacific Plate, heavier and denser, began to dive beneath the lighter continental crust in a slow-motion catastrophe known as subduction. Imagine a planet-sized wedge driving itself into the underbelly of a continent, the ocean floor folding downward while the land above was crushed, bent, and lifted toward the sky. It was the beginning of one of the greatest geological battles in Earth's history, the making of the Rocky Mountains. At first, the collision was far offshore. The edge of North America then lay hundreds of miles west of where it is today. Between the continent and the ocean stretched a chain of volcanic islands, born from magma leaking up through the subduction zone. As the Pacific Plate continued its relentless crawl eastward, these islands rode along like passengers on a moving walkway. One by one, they slammed into the continental margin, too buoyant to sink, too massive to stop. Each impact forced the seabed upward and inward. The crust crumpled, folded, and broke, stacking ancient sediments like cards in a deck. The once flat floor of the ocean became a rising wall of rock. The sea retreated, and the land began to heave. It was not a single event but a series of them, playing out over tens of millions of years. Each time an island arc collided, it welded itself to the continent and drove the land a little higher. With every collision, new ranges formed, while older ones eroded away. A geological relay race that slowly built the western backbone of North America. The first great pulse of uplift created what we now call the Canadian Rockies. Geologists studying these northern ranges found that the rocks were surprisingly orderly. Thin layers of limestone and shale lying almost horizontally, as if the mountain had simply been tilted rather than shattered. This provided an important clue. The mountains hadn't erupted from below, they had been shoved from the side. Thrust faults, they called them, giant fractures where sheets of rock, sometimes a mile thick, were pushed up and over each other like ice floes colliding on a frozen sea. The scale of these movements defies comprehension. In some places, ancient strata that once lay deep beneath the ocean floor were shoved 60 miles eastward, resting today atop much younger rocks. The Rockies, in their northern reaches, are a paradox. mountains made not by vertical explosion, but by horizontal compression. Geologist Ben Gad once compared it to pushing the skin of your hand across your knuckles. The bones, the continental plate, stay in place while the skin, the sedimentary layers, bunches and folds. Over millions of years, those folds hardened into peaks. The analogy may be simple, but the forces were anything but. Beneath the Rockies, pressures built up that could crack entire continents. And then, suddenly, the push stopped. After nearly 100 million years of collisions, the Pacific plate shifted direction. For a brief geological moment, perhaps 10 million years, the continent rested. The mountains, newly formed, began to erode. Rivers carved valleys, glaciers scraped their flanks, and the peaks began to crumble. But peace on a geological timescale is an illusion. The next impact was already on its way. 80 million years after the first phase of mountain building, another fragment of crust, another terrain, as geologists call them, slammed into the western edge of North America. This new collision reignited the forces of uplift. The seabed once again buckled and heaved, driving layers of rock higher and farther east. The cycle of compression began anew. By now, the Rockies stretched over 2,000 miles, from the frozen ridges of British Columbia to the deserts of New Mexico. But something strange was happening at their southern end, something that would change everything geologists thought they knew about how mountains form. In the north, the forces of uplift made sense. Classic subduction, island collisions, thrust faulting, the well-known script of plate tectonics. But as scientists moved south into the American Rockies, the pattern broke. The rocks were different, older, harder, composed of granite formed deep within the Earth's crust. And more puzzling still, these mountains were rising not near the edge of the continent but hundreds of miles inland. It was as if the power of the Pacific collision had somehow reached across the continent's heart and clenched its fist there. The answer, scientists now believe, lies in the changing angle of subduction. Around 70 million years ago, the Pacific plate stopped plunging steeply into the mantle and began sliding almost horizontally beneath North America, scraping along the underside of the continent like a spatula under a pancake. This shallow subduction transferred tectonic stress deep into the interior, warping the crust far from the coast and thrusting up mountain ranges in what should have been a stable, quiet region. This event, known as the Laramide erosion, was nothing short of revolutionary. It explained not only why the Rockies rose so far inland, but also why they are built largely from ancient basement rock. The granite foundations of the continent were shattered and uplifted, breaking through layers of younger sediment. Whole sections of crust tilted upward, creating the dramatic Front Range of Colorado and Wyoming. Even today, you can see the evidence of this violence at Red Rocks Park near Denver. There, tilted slabs of red sandstone lean sharply toward the sky, as if caught mid-motion in the act of breaking. Beneath them lie the exposed backs of billion-year-old granite peaks, the bones of the continent laid bare. It was a cataclysm measured in millimeters per year, imperceptible to any living creature, yet powerful enough to reshape half a continent. During the height of the Laramide erosion, the Rockies may have risen thousands of feet in less than 1 million years, geologically speaking, an instant. By the time the collisions subsided, the continent had been transformed. The Pacific shore had moved hundreds of miles west. What was once seafloor now stood among clouds. And beneath it all, the subducting plate continued its silent glide, carrying with it the seeds of yet another upheaval. Because when you push the Earth's crust for that long, something else happens. It bends, it cracks, it remembers. And even when the mountains stop rising, the land beneath them keeps shifting, storing energy like a coiled spring. That stored energy would later reveal itself in a new and unexpected form, not as uplift, but as a tear, a rift, a wound running down the heart of North America. The story of the Rockies, it seems, was not about a single collision, but a chain reaction, a symphony of subductions and rebounds that reached from the depths of the mantle to the highest peaks of the continent. And though the great collisions ended tens of millions of years ago, the echoes of those forces still travel through the crust, shaking it, heating it, whispering that the story is not yet finished. The Rockies were born in violence, forged by the slow fury of a planet at work. But their creation also set the stage for their destruction, and perhaps for the next chapter in Earth's continental saga. Part 3: The Shifting Earth, Faults, Folds, and the Rise of the Front Range. To understand the Rockies, you have to think in motion, not the motion of seconds or days, but of eons. The planet beneath your feet never stops moving. Every mountain, every valley, every ridge is a frame in a film that has been playing for hundreds of millions of years. We just happen to be watching it in slow motion. And the most extraordinary part of that film, the one that tells the story of how the Rockies truly took their shape, was written in the language of faults and folds. When you stand at the edge of Alberta's Mount Yamnuska, you can see that language carved into the land itself. The face of the mountain is sliced by a single, clean line that runs like a scar across the rock, the McConnell Thrust Fault. Above that line, the rock is 500 million years old. Below it, just 70 million. The older layers sit on top of the younger ones, as if time itself has been turned upside down. This isn't a mistake of nature. It's the signature of the forces that built the Rockies, forces that could fold and fracture the Earth's crust as easily as a human hand bends a book. At the height of the Laramide orogeny, the crust of western North America was under unimaginable pressure. The shallowly subducting Pacific Plate didn't just shove against the continent's edge. It scraped beneath it, compressing the rock layers and forcing them to buckle. When the pressure became too great, the crust didn't simply bend, it snapped. Huge slabs, sometimes tens of miles wide, broke loose and slid eastward along low-angle faults, stacking atop one another like cards in a collapsing deck. Geologists call this process thrust faulting. But that term doesn't capture the violence involved. Imagine a sheet of rock 5 miles thick and 200 miles long being shoved sideways faster than it erodes. The result is the distinct sawtooth pattern that defines the northern Rockies today. From the air, these peaks resemble frozen waves, each one a monument to the compression that folded them into being. At ground level, the evidence is more subtle but no less striking. Layers of sedimentary rock, once laid neatly on the ocean floor, are now tilted at impossible angles. Some layers dive vertically into the ground. Others stand on edge like the pages of a half-open book. In some places, the older rocks rest absurdly atop much younger strata, an inversion of time that makes no sense until you realize that the entire landscape has been turned inside out. For scientists, thrust faults are more than scars. They are windows into the hidden architecture of the continent. Each fault marks a place where the crust broke under strain, where deep forces overcame the resistance of stone. And yet, for all their violence, these faults also gave the Rockies their unique beauty. They created the steep cliffs, the sharp ridges, the endless terraces that catch the morning light like blades of glass. Still, mountain building alone doesn't explain the landscape we see today. For that, another artist must be credited. One as ancient and relentless as the mountains themselves: erosion. While tectonic forces pushed the Rockies upward, erosion was already pulling them down. Rain and wind carved their flanks. Rivers cut deep canyons into their sides. Over time, the balance between uplift and erosion became a kind of slow-motion duel, creation and destruction locked in perfect symmetry. The most powerful sculptor of all was water. In the colder regions of Canada and Montana, snow and ice accumulated year after year, compressing into massive glaciers that flowed downhill like rivers of slow glass. These glaciers gouged out U-shaped valleys, sliced through ridges, and carried away billions of tons of rock. When they melted, they left behind deep fjords and jagged spires, the iconic skyline of the northern Rockies. Even as glaciers carved the surface, the weight of the mountains themselves pressed downward on the crust, forming roots that extended miles beneath the surface. Geophysicists discovered that these roots could be 5 or 6 times deeper than the visible peaks above. The Rockies, they realized, were like icebergs. The part we see is only a fraction of the whole. And here's where the story takes a fascinating twist. When erosion removes the upper layers of a mountain, the weight on the crust decreases. The root responds by rising upward, bringing buried rocks closer to the surface in a process called isostatic rebound. In other words, every time erosion wears the Rockies down, the Earth itself lifts them back up, as if refusing to let them die. It's a delicate feedback loop, a geological balancing act between destruction and renewal. Without erosion, the Rockies would be featureless plateaus. Without uplift, they'd have vanished long ago. Together, they maintain a dynamic equilibrium that keeps the mountains alive. But not all parts of the Rockies were shaped equally. The Canadian Rockies, built mostly from layered sedimentary rock, are sharp, jagged, and pale, easily eroded but beautifully intricate. Farther south, in Colorado and New Mexico, the mountains change character. There, the peaks are darker, harder, made of granite that once lay deep within the Earth's crust. These southern ranges rise higher and resist erosion longer, their forms more massive and enduring. This transition marks a turning point not only in geology but in the continent's story. The northern Rockies are a monument to external forces: collisions, thrusts, compression. The southern Rockies, however, tell of internal upheaval, of heat and buoyancy rising from below. And somewhere between those two extremes lies the key to the Rockies' mysterious endurance: the hidden mantle. Deep beneath the Front Range of Colorado, geologists have found evidence of warm, buoyant material rising from the mantle, a subtle hot spot that continues to push upward even today. That gentle but persistent force explains why, despite millions of years of erosion, the Rockies still tower above the plains. They are not just relics of ancient collisions. They are participants in an ongoing conversation between the planet's surface and its molten heart. At the boundary where the Rockies meet the Great Plains, this dialogue becomes visible. The land drops abruptly from jagged peaks to open grassland, a frontier that marks the limit of uplift. Geologists call this the mountain front. To the west lies chaos: fractured rock, folded strata, remnants of ancient seas. To the east lies stability, a continent stretching unbroken to the Atlantic. Between them, at that invisible line, the Earth is still negotiating its shape. And perhaps in that negotiation lies the secret of why the Rockies endure. They are not static monuments but living boundaries, dynamic expressions of the balance between stress and release, between rise and fall. They remind us that even mountains are transient, that permanence on Earth is an illusion measured only in human time. So the next time you stand on a ridge in Colorado, with the wind cutting across the peaks and the plains stretching endlessly below, consider this: beneath your feet, the ground is still shifting. The rock you stand on was once buried miles beneath an ocean floor. The horizon you see is the edge of a collision that has been unfolding for 200 million years. And the story isn't over yet. The same forces that lifted these peaks may soon begin to tear them apart. Because even now, the crust beneath the Rockies is stretching again, and deep below, something is stirring. Part 4: The Fire Beneath: How the Mantle Reshaped the Rockies. Beneath the Rockies, something ancient and unseen is moving. Not the hard crust we stand upon, but the deep, molten world beneath it, the mantle. A vast, slow ocean of heat and pressure, flowing in currents that rise and sink over millions of years. It is there, in that dark underworld, that the real story of the Rockies begins to shift from one of compression to one of expansion. For most of Earth's history, the region that is now the western United States was dominated by one simple rule: plates collided, mountains rose. But around 30 million years ago, that rule began to change. The collision that had built the Rockies slowed, then faltered. The Pacific Plate, which for tens of millions of years had been scraping beneath North America, began to sink deeper again into the mantle, and as it did, it left behind a wake of molten turbulence. When the pressure of subduction lifted, the continent began to relax. The once compressed crust started to rebound, like a clenched fist slowly opening. But this was no gentle exhale. It was violent, uneven, and unpredictable. In some places, the crust thickened. In others, it began to stretch and tear apart. From deep within the Earth, magma surged upward along these tears, reheating the lower crust and thinning it from below. The heat weakened the rocks, allowing them to stretch even farther. Over millions of years, this cycle of heating and stretching transformed the entire landscape and gave rise to one of the most mysterious features in North America, the Rio Grande Rift. Running from central Colorado down through New Mexico into northern Mexico, the Rio Grande Rift is not a mountain range, but a wound, a long, deep gash in the continent's crust. From space, it appears as a faint but unmistakable line dividing the Rockies from the desert basins to the west. To the untrained eye, it might look like just another valley, but to geologists, it's a sign of something profound, the very beginning of continental separation. If you drive south from Denver toward Santa Fe, you are following that fault line, though most people never realize it. The mountains slowly fall away, the plains widen, and the ground beneath begins to thin. Volcanic fields dot the landscape, like small scars marking where the planet once bled. Each eruption, each uplift, each tremor is part of a single, ongoing story, the slow disassembly of a continent. It was here, in the 1970s, that scientists first discovered that the Earth's crust beneath the Rockies was unusually hot. Using seismic imaging, the geological equivalent of an MRI, they found that the crust was thinner than expected, and that waves of heat were rising from the mantle below. This discovery shocked the scientific community. For decades, the Rockies had been seen as the byproduct of compression. Now they seemed to be sitting atop a zone of expansion and heat. The implications were enormous. If the mantle beneath the Rockies was warming and rising, it could mean that the forces of uplift were not over. They had merely changed direction. The mountains, once born of collision, might now be sustained by buoyancy. In other words, the Rockies are still alive, not eroding into death, but quietly breathing from below. This rising mantle plume acts like a slow-motion geyser, pressing upward, stretching the crust, and feeding a string of volcanoes and geothermal fields along its path. One of the most visible examples lies just north of New Mexico, the San Luis Valley. It looks serene, a flat, high-altitude basin rimmed by distant peaks, but beneath it lies a cauldron of heat. The valley floor is actually a giant graben, a block of crust that has sunk between two diverging faults as the land pulls apart. If you were to slice the earth open here, you'd see the crust bending downward in a shallow U-shape, flanked by rising faults on both sides. And at the center, you'd see the molten glow of magma still creeping upward from the mantle. Not enough to erupt, but enough to keep the land restless. Geophysicists believe the Rio Grande Rift may be the first stage of something much larger, the eventual fragmentation of the North American continent. Over tens of millions of years, they predict, the rift could widen, forming a new ocean basin. The Rockies, which now mark the heart of the continent, could one day become its edge. It's a vision that's both thrilling and terrifying, a reminder that the ground beneath us is temporary, that the boundaries of nations and continents are written in sand compared to the patience of the planet. What we call solid ground is merely a pause between movements, but not everyone agrees on the cause of the rift. Some geologists argue that the mantle plume theory doesn't fully explain the pattern of deformation. Instead, they suggest that the crust itself, weakened by the ancient stresses of the Laramide orogeny, simply began to tear apart under its own weight, a geological fatigue failure on a continental scale. In this view, the rift is less a new beginning than the slow unraveling of old wounds. Either way, the signs are impossible to ignore. Along the rift's path, seismic activity continues. Hot springs bubble up, releasing gases from deep within the mantle, helium, carbon dioxide, even traces of neon. Satellite measurements show that the region is still stretching, ever so slightly year after year. And deep beneath the surface, seismic waves travel slower than they should, suggesting pockets of partial melt. Magma reservoirs waiting, perhaps, for the right conditions to rise. The most dramatic evidence came in 2009, when a team from the U.S. Geological Survey detected a massive zone of anomalous heat beneath Colorado and New Mexico, a feature stretching hundreds of miles wide. They called it a mantle upwelling, a plume of warm rock rising from the Earth's depths. It wasn't as intense as the hotspot that fuels Yellowstone, but it was enough to lift the surface of the Rockies by several hundred meters over the past 10 million years. That's right, the Rockies are rising again. Not rapidly, not dramatically, but undeniably. While erosion wears their peaks down, the mantle below keeps pushing upward, like a sleeping giant refusing to sink. The result is paradoxical. A mountain range that erodes and grows at the same time, locked in perpetual equilibrium. This realization has changed how scientists view the entire interior of North America. The continent, once thought stable and immovable, is in flux. Hidden beneath the quiet forests of Colorado and the desert basins of New Mexico lies a region of heat, tension, and motion. A slow but relentless force that may one day split the land in two. And yet, for now, that transformation is invisible. The rivers still flow, the highways still cross the valleys, and the mountains stand serene against the horizon. The danger, if it can be called that, is measured not in human years but in epochs. Still, there's a poetic irony in it all. The Rockies were born from collision, and they may die by division. The same deep fire that once welded continents together now threatens to pull them apart. If you could journey down through the crust, through the fractured granites and ancient sedimentary layers, you would eventually feel the heat rise. The air would shimmer, the stone would soften. You would reach a place where rock moves like honey, where time is measured in convection cycles, not clocks. And there, in the silent glow of the mantle, you'd see it. Slow, steady movement, pushing upward with the patience of a god. That's the true engine of the Rockies. Not wind or rain or ice, but the restless fire below. And it has only just begun to stir again. Part 5, The Silent Forces. How scientists discovered the Rockies are still rising. At first glance, the Rockies look eternal, cold, ancient, immovable. They tower over the plains like titans asleep, their granite bones bathed in sunlight, their peaks sharp against the blue. But what if they aren't sleeping? What if, beneath that illusion of stillness, the entire range is slowly, almost imperceptibly, rising? It was a question no one seriously asked until the late 20th century. By then, the Rockies were considered an old range, a monument to an era of geological violence long since ended. The collisions that built them had ceased tens of millions of years ago. The tectonic plates had settled into a quieter rhythm. And yet, something didn't add up. When scientists compared old survey data with modern satellite imagery, they noticed subtle inconsistencies. Small differences in elevation that shouldn't have been there. The ground, it seemed, had moved. At first, they blamed measurement errors, atmospheric interference, even thermal expansion of instruments. But the more precise the measurements became, the harder it was to deny. The Rockies were not static. They were shifting, not sinking, as erosion alone would suggest. Rising. In 2003, a team from the National Geodetic Survey began deploying an array of high-precision GPS receivers across the Rocky Mountain region, from Montana down to New Mexico. Unlike the GPS devices used in cars, these were designed to detect changes in position of just a few millimeters per year. Each receiver was anchored deep into bedrock, transmitting constant signals to orbiting satellites. Over time, those signals revealed something remarkable. The entire central spine of the Rockies was creeping upward at a rate of 1 to 2 millimeters per year. That's about the thickness of a credit card, almost nothing to the human eye. But in geological terms, it's staggering. Over 1 million years, that's more than a kilometer of vertical uplift. And no known tectonic collision could account for it. So where was the force coming from? The answer, once again, pointed downward, to the mantle, that vast reservoir of heat and movement beneath the crust. Using seismic tomography, a technique similar to medical CT scans but applied to the Earth, researchers discovered that the mantle beneath Colorado and New Mexico was hotter and less dense than expected. Waves from earthquakes traveled slower through this region, suggesting the presence of partially molten rock rising from below. This mantle anomaly, as it was called, wasn't uniform. It pulsed, a fluctuating pattern of warmth that shifted slowly over time, like a heartbeat in stone. The heat, scientists realized, was expanding the crust from below, causing it to lift gently upward even as erosion gnawed at it from above. In effect, the Rockies were being inflated from within. To test this, researchers combined GPS data with gravity measurements from satellites like GRACE, the Gravity Recovery and Climate Experiment. GRACE, launched by NASA and the German Aerospace Center in 2002, measures minute variations in Earth's gravitational field. When mass moves, whether it's groundwater, ice, or molten rock, gravity changes slightly. Over the Rockies, GRACE detected a persistent decrease in gravity, suggesting that the crust was indeed becoming lighter and more buoyant. The pattern matched perfectly with regions of documented uplift. It was as if the mountains were floating upward on a slowly rising tide of molten rock. But the discovery came with an unsettling implication. If the crust was rising, it wasn't doing so evenly. Some regions, particularly around the Rio Grande Rift, were moving faster than others. The differential motion meant that stresses were accumulating again, hidden deep below the surface. Small earthquakes began to cluster along the edges of the rift zone, subtle reminders that the Earth was adjusting to forces still in play. To visualize what was happening, geophysicist and Sheehan from the University of Colorado created a three-dimensional model of the mantle beneath the Rockies. What she found defied expectation. Instead of a uniform layer of crust resting atop a steady mantle, the boundary was jagged, undulating, like waves frozen in stone. In some areas, the crust had thinned dramatically. In others, it bulged upward. Beneath central Colorado lay a massive pocket of warm, partially molten material, a sort of subterranean blister pressing against the continent's underside. It was a breathtaking realization. The Rockies, long thought to be a fossil of Earth's tectonic past, were in fact a living, breathing structure, still responding to the convective pulse of the mantle below. And yet, this discovery didn't just rewrite the story of the Rockies. It called into question something much larger, the stability of North America itself. If the continent's heart was still being lifted by mantle upwelling, could it also be stretched, cracked, or even torn apart in the future? Was the Rio Grande Rift merely a local feature, or the early scar of a much greater fracture to come? To explore these questions, scientists turned to one of the most advanced geophysical experiments ever conducted on the continent, EarthScope. Launched in 2004, EarthScope deployed more than 400 portable seismometers across the U.S., spaced roughly 70 kilometers apart, forming a giant moving network that listened to the planet's inner rumblings. As seismic waves from distant earthquakes passed through, each sensor recorded how the waves changed speed and direction. By compiling this data, geologists could create a 3D map of what lay beneath the surface, from the crust down to the mantle. What they found beneath the Rockies stunned even the most skeptical scientists. Deep under the mountain belt, extending from Wyoming to New Mexico, they detected a vast column of hot, buoyant material rising slowly from the mantle. A plume nearly 1,000 kilometers wide. This structure, invisible from the surface, was acting like a cushion beneath the continent, subtly pushing upward while also stretching the crust around it. The discovery was both beautiful and terrifying. It explained the GPS data, the gravity anomalies, even the small earthquakes along the rift. But it also meant that the Rockies, and perhaps all of central North America, sit atop an active, restless zone of the planet. In short, the continent we live on is breathing. Every few centuries, the mantle releases more heat, the crust expands, and the surface lifts a few millimeters higher. Then, as the cycle cools, the land relaxes again. To us, it's imperceptible. To the Earth, it's as natural as a heartbeat. The data also revealed something subtler. The uplift wasn't confined to the Rockies. The entire interior of North America, from the Great Plains to the Mississippi Basin, was moving, rising, and falling in slow waves. Like a bedsheet stirred by a giant beneath it, the continent rippled with silent motion. The realization hit scientists with the weight of poetry. The land beneath us is not solid, not still, not safe from change. It moves in whispers, in tremors too faint to feel, in the size of magma turning beneath miles of stone. And so the image of the Rockies as ancient and eternal is, in truth, an illusion. They are young, restless, dynamic mountains that continue to climb while the world believes they are fading. When the first surveyors mapped their peaks, they thought they were charting permanence. What they were really doing was capturing a moment in motion, a single frame in a film that's been rolling since the dawn of the continent. The Rockies are still rising, and if they are, then perhaps nothing about our world is ever truly at rest. Part 6, Echoes in Stone, Tracing the Past Through the Future. Every mountain tells a story. But the Rockies don't whisper theirs in words. They speak in isotopes, in layers of sediment, in the frozen echoes of time locked inside stone. To read their history, scientists must learn to listen to the planet in ways no human ear ever could. And when they do, what they find is staggering. Because the more deeply we look into the Rockies' past, the more we see our own future written there. It begins with the simplest element of all, oxygen. Inside every grain of rock and speck of ice, the oxygen atoms record the temperature and pressure of the moment they formed. By studying the ratios of different oxygen isotopes, lighter O16 and heavier O18, geochemists can reconstruct ancient climates, ancient altitudes, even the elevation of vanished landscapes. When scientists began sampling rocks and river sediments across the Rockies, they found something unexpected. The isotopic fingerprints didn't match the elevations predicted by classical tectonic models. In other words, the Rockies may not have always been as tall as we think. Their height, their majestic, sky-piercing form, is a recent flourish in a much longer evolution. This revelation came from a technique known as paleoaltimetry, literally the measurement of ancient altitudes. By analyzing the isotopic composition of ancient soil carbonates, scientists can estimate how high the land stood when those soils formed. The results painted a surprising picture. Between 70 and 40 million years ago, much of the interior of what is now Colorado and Wyoming sat at elevations nearly 1,500 meters lower than today. The high plateaus and deep basins we see now were sculpted later, during a slow, post-tectonic uplift driven not by collisions but by buoyancy. It was the mantle again, always the mantle. As the subducted Pacific plate sank deeper into the Earth and detached from the underside of the continent, it created space. A void that rising, lighter mantle material rushed in to fill. The process, called delamination, caused the entire region to rebound upward like a ship released from its anchor. This late uplift, occurring long after the original mountain building had ceased, reshaped the Rockies into their modern form. To confirm this, researchers turned to another tool, thermochronology. By measuring the concentration of radioactive isotopes like uranium, thorium, and helium within minerals, scientists can determine when those minerals cooled, that is, when they were brought closer to the surface by erosion or uplift. The cooling ages from rocks across the Rockies told a consistent story. Major uplift continued well into the last 20 million years, long after traditional models said it should have stopped. The mountains, it seemed, were still young. Yet, as scientists traced these isotopic clues, they began to notice patterns that extended beyond geology. The rise of the Rockies coincided with dramatic changes in global climate, the cooling that ended the Eocene greenhouse world and ushered in the ice ages. The mountains didn't just record the passage of time. They influenced it. By pushing air upward, the Rockies created new weather patterns, trapping moisture on their western slopes and casting rain shadows to the east. This reshaped ecosystems, carving deserts and prairies where forests once stood. Rivers like the Colorado and the Missouri were born from these shifts, cutting deep canyons and carrying sediment thousands of miles away to form the Great Plains. The Earth, it seemed, was re-engineering its own surface, using the Rockies as both sculptor and signature. Modern researchers can now trace those changes almost year by year, thanks to the precision of satellite sensors and isotopic dating. In the ice cores of Greenland, they find layers of dust that originated in the Rockies, each one a time capsule of wind, erosion, and global climate. In deep-sea sediments, they detect chemical fingerprints of rivers that once flowed from these peaks millions of years ago. Even the carbon locked in fossil leaves tells the same story. The rise of the Rockies cooled the region, changed rainfall, and set in motion the cycles that would eventually define North America's ecosystems. But perhaps the most haunting evidence of the Rockies' continuing evolution lies not in ancient rocks, but in the thin air above them. In 2014, researchers from the University of Wyoming launched a high-altitude balloon over the Front Range, carrying sensors designed to measure isotopic changes in atmospheric carbon dioxide. What they found was subtle but profound: trace differences in the ratios of carbon isotopes that matched the slow but measurable uplift of the land below. Even the atmosphere, it seems, can feel the Rockies' rise. This realization reframed the entire discussion of geological time. Mountains were no longer static relics of the past. They were active participants in shaping the planet's present and its future. Their rise and erosion regulate global carbon cycles, influence ocean currents, and even alter the trajectory of evolution itself. It's easy to think of mountains as boundaries, the edges of worlds, but in truth they are engines. Every grain of sand on a distant beach may once have been a particle of the Rockies, carried by rivers across the continent and deposited into new forms. Every shift in climate, every river's path, every living thing on the plains owes part of its existence to the pulse of these mountains. And if that sounds poetic, it's because it is. The Rockies are the poetry of Earth written in stone. Still, even poetry has its mysteries. As geologists dig deeper into the mountain's core, they encounter puzzles that defy simple explanation. Some granite formations are much younger than expected, intruding into older rocks with no clear tectonic source. In certain valleys, erosion appears to have accelerated in recent millennia, far faster than climate alone can explain. Could it be that the mantle's warmth beneath the Rockies is again intensifying? Could we be witnessing, in slow motion, the opening lines of a new geological chapter? The evidence hints that we might. Thermal imaging from satellites shows subtle but consistent warming in the crust beneath parts of Colorado and northern New Mexico. Ground deformation data from INSAR, interferometric radar, satellites reveal tiny uplifts, mere millimeters each year, that correspond almost exactly with the pattern of mantle upwelling identified by the EarthScope project. The land, in other words, is whispering again. Not loudly enough to shake cities or split valleys, but just enough for those who listen carefully to hear. This is where the story folds back on itself, where the past becomes a mirror for the future. The same processes that lifted ancient seas into mountains are still at work today, though we measure them with lasers and satellites instead of fossils and strata. And the same rhythms that once tore Pangaea apart may one day open new oceans in the heart of North America. When you touch a rock in the Rockies, you are touching both past and prophecy. The atoms within that stone have lived through fire and flood, through compression and release, through the rise and fall of continents. They will outlast us, but they are not immune to change. They too will crumble, drift, and reform, joining the endless cycle of the Earth's rebirth. In that sense, the Rockies are not a monument to permanence but to transformation, a reminder that even the mightiest structures of the natural world are only temporary expressions of something deeper and more enduring, the restless motion of the planet itself. And so the echoes continue, not fading but evolving. The stones remember what we have yet to learn. Part 7, The Great Divide. How water, time, and gravity carved the soul of the Rockies. Long before highways traced their paths through these valleys, before climbers reached the summits or rivers carved their canyons, there was only silence and water. Endless, patient, unrelenting water. If the collision of tectonic plates built the Rockies, then it was water, aided by time and gravity, that gave them their shape, their spirit, their soul. At the heart of this story lies an invisible line, stretching from Canada to New Mexico, dividing the continent in two. They call it the Continental Divide, but to the Earth it's something far more profound. The scar where destiny splits. Every raindrop that falls upon the Rockies must choose a side. To the west, the water journeys toward the Pacific, through the Colorado River, slicing its way into the Grand Canyon, or through the Columbia, roaring toward the sea. To the east, it flows into the Mississippi and Missouri, winding across the plains before vanishing into the Gulf of Mexico. This single, invisible line, a ridge that barely registers underfoot, determines the fate of oceans. But the divide wasn't born from cartography or climate. It was carved by time, by the slow, stubborn war between uplift and erosion. And it is in this balance that the Rockies reveal their true genius. When the mountains first rose, their peaks were raw and jagged, newly torn from the earth. Rain fell upon their surfaces, finding cracks and weaknesses, seeping into their stone. Every drop that froze overnight expanded with the quiet force of dynamite, prying the rock apart. Over millennia, this freeze-thaw rhythm broke whole summits into talus slopes, seas of shattered stone that still gleam beneath the morning sun. Then came the rivers. Even as the Rockies rose, rivers like the Colorado, the Snake, and the Platte were already cutting downward, their flow accelerating as the gradient increased. Water is the planet's most persistent sculptor. It never sleeps, never ceases, and always finds the lowest path. Over millions of years, these rivers carved deep canyons, slicing through layers of rock that recorded ancient seas and vanished forests. One of the great mysteries of the Rockies is that many of these rivers predate the mountains themselves. They began flowing when the land was still flat, long before uplift began. As the Rockies rose beneath them, the rivers simply kept cutting downward, maintaining their courses while the land around them lifted skyward. It's as if the rivers refused to move, a phenomenon geologists call antecedence. The Colorado River is the most famous example. For over 20 million years, it has gnawed its way through the rising land, carving the Grand Canyon not by sudden violence, but by ceaseless persistence. Drop by drop, grain by grain, it has transformed mountains into monuments, valleys into cathedrals. But water alone could not have done it. The mountains were still too strong. So the Earth lent it another ally, ice. About 2.6 million years ago, the planet entered the Pleistocene, the Great Ice Age. Glaciers formed high in the Rockies, vast rivers of frozen water grinding their way downhill. Unlike liquid rivers, glaciers carry everything, boulders, soil, entire ridges, locked within their bodies. As they moved, they gouged the bedrock, reshaping valleys into the broad U-shapes we see today. In places like Banff, Jasper, and Glacier National Park, you can still trace the paths of these vanished titans. Cirques, moraines, and hanging valleys tell of their passage, the scars of a time when the mountains wore crowns of ice that stretched for hundreds of miles. When the glaciers finally melted, they left behind alpine lakes, fertile valleys, and rivers that still follow the channels carved by their frozen ancestors. And so the Rockies were sculpted, not in one cataclysmic event, but through a dialogue between stone and water, ice and air, weight and buoyancy. Every curve of every ridge, every canyon and basin is the result of millions of tiny decisions made by gravity and time. This process continues even now. Every summer, meltwater from glaciers feeds streams that sparkle down the slopes, carrying silt and sand to the valleys below. Every storm, every winter freeze, every lightning strike adds another stroke to the planet's slow masterpiece. If you could speed up time, the Rockies would appear to breathe, rising and eroding, swelling and shrinking, in cycles of geological respiration. But perhaps the most poetic revelation of all is that erosion sustains the mountains. It seems paradoxical, destruction preserving creation. Yet as rivers and glaciers strip away rock, they also lighten the load on the crust. The Earth responds by pushing upward, maintaining equilibrium. The more they erode, the more they rise. In this way, the Rockies are a perfect metaphor for resilience. The more they are broken, the more they stand tall. Scientists studying sediment transport have even traced the journey of these eroded grains. Tiny particles that once formed the highest peaks, now drifting eastward across the continent. Much of the fertile soil of the Great Plains, it turns out, is made from the dust of the Rockies. The breadbasket of America, its wheat, corn, and grasslands, all exist because the mountains have been slowly crumbling for millions of years. Life itself, nourished by decay. And yet, the process is far from over. Modern climate data show that the glaciers of the Rockies are retreating at an alarming rate. Places that were once frozen year-round, like the Athabasca Glacier or the Icefields Parkway, are melting faster than at any point in the last 10,000 years. As the ice vanishes, rivers swell, flooding valleys and accelerating erosion. Entire ecosystems shift in response. It's as if the mountains are entering another cycle, one we are witnessing in real time. What took nature eons to build, climate can alter in centuries. Still, in this apparent fragility lies a strange kind of hope. The same processes that tear the mountains down will one day build new ones. Every rock broken becomes sediment. Every sediment, a seed for the next range. The earth wastes nothing. It only recycles grandeur. When you stand atop the divide, perhaps at Loveland Pass, or at Logan Pass where the snow still lingers in July, you can feel that duality. The rivers whisper beneath you, one to each ocean. The air is thin, but full of movement. The land seems eternal, yet you know it is vanishing, atom by atom, into the rivers below. It's humbling to realize that every mountain peak is temporary, every horizon fleeting. But that impermanence is what makes them alive. The Rockies are not a finished sculpture. They are an ongoing performance, a collaboration between Earth's elements that began long before us and will continue long after we're gone. They rise, they fall, they rise again. And through it all, they carry the memory of oceans, the patience of glaciers, and the defiance of rivers that never stop running. Water carved their body, time shaped their soul, and gravity, quiet, constant gravity, keeps the story going. Part 8: The Hidden Rivers, the underground world beneath the Rockies. We think of mountains as solid things, colossal, unyielding, immutable. Yet beneath the Rockies lies another world, one that flows, breathes, and shifts like the bloodstream of the continent itself. It's an unseen realm of rivers that never see the sun, caverns carved by time and water, and vast reservoirs of ancient rain trapped within stone. If the peaks above tell the story of power and collision, then the world below whispers the tale of patience, the quiet labor of water in the dark. It begins where the visible rivers disappear. Beneath the valleys of Colorado, Wyoming, and Montana lies a labyrinth of karst systems, networks of limestone and dolomite sculpted by acidic water over millions of years. Each droplet of rain that seeps into the ground carries with it a small measure of carbon dioxide, dissolving minerals as it travels downward. Slowly, silently, it hollows out the rock, forming tunnels, chambers, and underground streams that stretch for miles. In the Flatirons outside Boulder, you can trace the boundary where surface streams vanish into the earth, feeding aquifers deep below. Farther south, near Glenwood Springs, entire underground rivers rise again in bursts of geothermal heat, hot springs bubbling with minerals drawn from the mantle's warmth. The water that emerges there has been underground for thousands of years, tracing a path through layers of stone older than humanity itself. For geologists, these springs are more than natural wonders. They are time machines. Each contains a chemical signature that reveals its journey, temperature, pressure, isotopic ratios of hydrogen and oxygen, even trace gases from deep within the mantle. By studying them, scientists can map the invisible plumbing of the Rockies, the pathways by which water circulates from rain to rock to magma and back again. What they've found is astonishing. The Rockies aren't just a mountain range, they're a giant hydrological engine. Rain and snowmelt percolate downward through fractures, where they're heated by the warm crust and then rise again, carrying dissolved minerals to the surface. Some of that water emerges as hot springs, some feeds rivers, and some stays locked underground for tens of thousands of years. The entire system acts like a slow, breathing lung, inhaling and exhaling water in cycles that mirror the pulse of the planet. One of the largest of these hidden systems lies beneath the San Juan Mountains in southwestern Colorado. Here, ancient volcanic rocks hold vast aquifers that stretch for hundreds of miles, supplying water to distant valleys and towns. The water that flows from these depths is rich in sulfur, iron, and lithium, elements that hint at the fiery origins of the land. Nearby, in Pagosa Springs, temperatures can reach 65 degrees Celsius, hot enough to melt wax, yet pure enough to drink. Scientists analyzing the isotopic composition of the water found traces of helium-3, a rare isotope that originates only in the mantle. It's proof that the Earth's deep interior still communicates with the surface, even here, in the quiet heart of the continent. But not all the hidden water is born of heat. In the northern Rockies, the ancient limestone of the Madison Formation conceals one of North America's largest freshwater reservoirs. The Madison Aquifer holds more than 1,000 cubic kilometers of water, enough to cover the entire state of Colorado in a layer 5 meters deep. This vast underground sea predates the Ice Age. Some of its water has been trapped since the last glaciation, sealed within the rock by layers of impermeable shale. In a way, it's a fossil ocean, still alive beneath our feet. And it moves, slowly, silently, with the patience of mountains. Computer models show that groundwater in the Madison system can take tens of thousands of years to complete a single circuit, descending through fractures, migrating laterally, then rising again through artesian springs. It's a process so slow that by the time the water reemerges, continents may have shifted and climates changed. To the human mind, that timescale is almost impossible to grasp. But to the Earth, it's simply the rhythm of breath. The same slow circulation that nourishes life also shapes the land itself. As groundwater flows through soluble rocks, it enlarges fractures into voids, voids into caves, and caves into cathedrals. In the Pryor Mountains of Montana and the Bighorn Range of Wyoming, entire cave systems extend for miles, the product of millions of years of underground erosion. Stalactites and stalagmites grow there at the rate of a few centimeters per millennium, each one recording tiny fluctuations in temperature and rainfall like rings in a tree. By analyzing the isotopic layers of these mineral formations, known as speleothems, scientists can reconstruct a continuous climate record stretching back hundreds of thousands of years. The caves, it turns out, are not merely voids. They are archives. Within their silent chambers, the Rockies keep a diary written in calcite and time. Even the colors of the rock tell stories. Iron oxides paint the walls in shades of red and gold, traces of ancient oxygenation events, when Earth's atmosphere first filled with breathable air. Manganese leaves streaks of black, marking the presence of water that once carried nutrients through the stone. To wander such caves is to walk through a library where every mineral is a word and every drip of water a whisper from the past. But this hidden world is fragile, and in some ways more endangered than the peaks above. Human activity, from groundwater extraction to mining, has begun to alter the delicate pressure systems that sustain these underground rivers. When aquifers are drained too quickly, the overlying rock can collapse, forming sinkholes that swallow fields and forests. When pollutants seep into the soil, they travel through the same invisible channels that water does, contaminating springs miles away. The Earth, which has filtered its own water for millions of years, is losing its patience with us. Still, for all its vulnerability, the subterranean Rockies remain one of the planet's most mysterious frontiers. In recent years, teams using fiber optic sensors and seismic microarrays have begun to detect faint vibrations beneath the surface, the sound of groundwater moving through fractures, almost like a heartbeat. The discovery has opened an entirely new field, hydroseismology, the study of how water and rock interact in real time. By listening to these signals, scientists can now watch underground floods, seasonal recharge cycles, even detect the slow flexing of the crust as aquifers expand and contract. It's the geology of sound, a music of pressure and flow. All this points to a profound truth. The Rockies are not just a surface phenomenon. They are a living system, extending from the clouds to the core, an unbroken chain of cause and effect linking atmosphere, mountain, river, and mantle. The rain that falls today may, in 1,000 years, become the mineral spring that rises in the desert. The water we drink carries within it the memory of mountains long vanished. The ancients might have called that magic. We call it hydrology, but in essence, It's the same awe, the recognition that everything is connected, and that even the mightiest mountains are porous hearts, pumping life through the veins of the earth. So the next time you stand at the mouth of a hot spring or peer into the darkness of a cave, remember, you are looking at the Rockies from the inside out. Beneath the hard stone lies movement, warmth, and memory, the hidden rivers that never rest. And somewhere far below, where the rock grows soft and the heat of the mantle begins to glow, the water turns to vapor, rising again, completing the endless cycle of mountain and rain. Part 9, The Pulse of Continents, How the Rockies Connect to Global Change. From space, the Rocky Mountains look like a scar, a single silver vein running across the green and brown skin of North America. But if you could watch the Earth and fast forward, a million years condensed into a minute, you'd see that scar shimmer and shift, as if the entire continent were breathing through it. That pulse, invisible to the eye but written in the crust, links the Rockies not just to the story of North America, but to the living heartbeat of the entire planet. To understand that connection, scientists look outward, beyond the boundaries of a single range, and trace the invisible cords that tie every mountain chain, ocean trench, and volcanic arc into one vast, dynamic network. The Rockies, the Andes, the Himalayas, even the Mid-Atlantic Ridge, they are all organs in the same body, the Earth's tectonic engine. And like a body, the planet's health depends on how those organs move, release heat, and exchange energy. In the case of the Rockies, their rise has been more than a geological spectacle. It has reshaped wind patterns, diverted rivers, shifted climates, and even changed the chemistry of the oceans. Over tens of millions of years, as rain and glaciers ground the mountains into dust, that dust carried essential minerals, calcium, iron, phosphorus, into the sea. Their microscopic plankton used those minerals to build shells and absorb carbon dioxide. Every mountain eroded became a small act of planetary cooling. It's a feedback loop that links rock and climate in a slow, intricate dance. Mountains rise, they expose fresh rock to weathering. Carbon dioxide dissolves in rainwater and reacts with minerals, and the products wash into the ocean, where they are locked away for millions of years as limestone. The higher the mountains, the faster the drawdown. The faster the drawdown, the cooler the planet becomes. The Rockies, like all great ranges, are both architects of landscape and regulators of atmosphere. We know this not from theory but from data buried deep in the planet's memory. Marine cores drilled off the coast of California show chemical signatures that match the timing of Rocky Mountain uplift. Around 35 million years ago, as erosion accelerated, levels of carbon isotopes in the ocean shifted sharply, a signal of falling atmospheric CO2. At the same time, global temperatures dropped, ice began to spread across Antarctica, and a new epoch of planetary cooling began. In a sense, the Rockies helped end Earth's ancient fever. But the influence goes both ways. Just as the mountains cooled the planet, the changing climate reshaped the mountains. During the ice ages, massive glaciers advanced and retreated across North America, their weight bending the crust downward. When they melted, the crust rebounded, amplifying the very uplift that had first drawn the ice. The cycle became self-reinforcing. Cold brought ice, ice carved valleys, valleys increased precipitation, and precipitation fed rivers that further eroded the peaks. Even today, traces of that rhythm persist. GPS data reveal subtle vertical oscillations in the Rockies, rises and falls of just a few millimeters each year as the planet's hydrological load shifts with the seasons. In wet years, the mountains sag under the added weight of water and snow. In dry years, they rise. The Earth is elastic, flexing to the beat of rainfall and drought. This sensitivity has drawn new attention in the age of climate change. As the atmosphere warms and glaciers retreat, the balance of mass across the continents is shifting once more. Meltwater from the Rockies flows toward the oceans, ever so slightly lightening the land. And the crust responds, rising in compensation, a geological echo of our warming world. What we see on satellites today, those subtle uplifts, are, in effect, the mountains breathing in response to humanity's impact. The connection runs even deeper. Beneath the Rockies, the same mantle currents that sustain their buoyancy also play a role in the global circulation of heat. As these currents move, they influence where volcanoes form, how ocean ridges spread, and even how continents drift. When one region of the mantle rises, another sinks, completing a planetary conveyor belt that redistributes energy from the core to the crust. It is this conveyor, this constant churning of stone, that makes Earth unique among the planets. Without it, the world would be geologically dead, like Mars or the Moon. No mountains, no oceans, no atmosphere worth breathing. The Rockies are part of that miracle, proof that the Earth is still alive. In recent years, geophysicists have begun mapping how these deep flows interact with the surface using global seismic arrays. What they found surprised them. The plume beneath the Rockies is connected, however faintly, to the same vast mantle cell that feeds volcanic activity along the Pacific Ring of Fire. Energy moves between these regions like currents between oceans. A tremor in Alaska, a quake in Chile, even an eruption in Japan, all send faint ripples through the same subterranean network. The continents, in other words, are not isolated. They are conversations written in stone. Understanding those connections has become more urgent as we enter a new era of climate and tectonic instability. Sea levels rise, glaciers shrink, and as weight shifts from land to ocean, the stresses on the crust redistribute. Scientists call it isostatic adjustment, but its implications are immense. Changes in surface mass can trigger fault movement thousands of miles away. There is mounting evidence that the melting of North America's ice caps is subtly increasing seismic activity along its mountain belts, a reminder that what happens in the atmosphere can awaken the ground below. The Rockies, sitting at the crossroads of these systems, are a kind of planetary sensor, a seismograph for Earth's internal and external changes. Their uplift, erosion, and rebound mirror the state of the world. When the planet warms, they rise. When it cools, they bow. Their rivers carry the chemical fingerprints of our age: nitrogen from agriculture, mercury from coal, microplastics from our machines, all flowing into oceans that remember everything. And yet, even amid this anthropogenic layer, the deeper rhythm persists. The mantle doesn't care about our timelines. The crust continues its cycles, slow and sure. The mountains will outlast us, but they will not forget us. In the sediments of future ages, the record of our civilization will be there. Thin lines of ash, traces of metals, isotopic spikes marking the age when humans briefly joined the planet's symphony. From a cosmic perspective, the Rockies are both fragile and eternal, fragile in form, eternal in motion. Their peaks may erode, their glaciers melt, their forests burn, but the forces that built them will build again. Perhaps 10 million years from now, another generation of mountains will rise where these now stand, fed by the same currents of molten rock that pulse beneath our feet today. Standing on a ridge at sunset, when the air turns copper and the shadow of the divide stretches eastward across the plains, it's hard not to feel that pulse. You can't hear it, but you can sense it, in the trembling of the ground after a distant storm, in the warmth that seeps up through the soil, in the endless patience of the horizon. That's not just wind or gravity. That's the heartbeat of the planet. The Rockies remind us that Earth's story is not static. It's a dialogue between water and fire, air and stone, life and time. And we are part of that conversation whether we realize it or not. Every footprint we leave, every mountain we climb, every resource we consume feeds back into the same endless cycle that has been shaping this world for 4 billion years. The pulse will continue long after us, but for now we are here to feel it, to listen, to understand that the line of mountains that cuts our continent in half is also the line that connects us to everything. Part 10, Whispers of the Future, What the Rockies Tell Us About the Fate of Continents. In the deep time of the Earth, nothing stays still. Continents drift, oceans close, mountains rise and fall, each in their turn, like waves upon a planetary sea. The Rockies are but one crest in that ocean, a temporary expression of forces that have been reshaping the world since before life began. But if we've learned to read their stones, then those stones also whisper what comes next. And what they say is this: North America is changing again. When geologists peer tens of millions of years into the future, they don't see a continent that looks like ours. They see one split open, torn along a scar that already exists, running quietly through Colorado and New Mexico, the Rio Grande Rift. To most of us, it's a valley wide, sun-drenched, filled with sagebrush and the scent of dust. But to the Earth, it's an incision, the first hint of a fracture that may one day become an ocean. If history is any guide, that fracture will widen. The Atlantic Ocean began this way, as a rift splitting the supercontinent Pangaea about 180 million years ago. What was once a shallow valley in Central Africa filled with lakes and rivers eventually tore apart, flooding with seawater and becoming the Atlantic Basin. The same may be happening beneath our feet now in slow motion, in the heart of North America. The signs are all there. The crust is thinning. The mantle below is rising. Volcanic fields line the edges like a trail of sparks. Every few centuries, a new eruption dots the landscape. Not catastrophic, but steady. A reminder that the rift is alive. In places like Taos and Socorro, the land itself is stretching, measurable by satellites, widening at a rate of a few millimeters each year. It sounds negligible, but give the Earth 10 million years, and that quiet movement becomes a gulf hundreds of kilometers wide. Imagine it. The Rockies standing as cliffs at the edge of a newborn sea, waves breaking against the skeletons of mountains that once crowned a continent. To the west, a fragment of crust carrying California and the Pacific coast drifts away, forming a new landmass, a mirror of what once happened when Africa split from South America. The map of the world will change, but the process will be the same: slow, patient, inevitable. Geologists call this cycle Wilson's cycle, after the Canadian geophysicist J. Tuzo Wilson, who first described how continents tear apart and reassemble over time. Each cycle lasts roughly 500 million years. Oceans open, close, and open again, in a rhythm as old as the planet. The Rockies mark one chapter of that rhythm, the uplift that came after a long compression. What comes next, by that same logic, is expansion. The Rio Grande Rift is not alone. Across the western United States, subtle fractures mark the crust like tension lines on a drum. The Basin and Range Province, stretching from Utah to Nevada, is another vast region of extension, the land there literally being pulled apart. Satellite data show that the western half of North America is stretching east-west, while the eastern half remains stable. The Rockies, caught between, are the hinge, the fulcrum around which the continent bends. And where there's bending, there's breaking. If current models hold, the rift will continue to deepen. In a few million years, volcanic activity may increase as magma rises to fill the gap. The San Luis Valley could sink below sea level, becoming an inland basin. Lakes will form, then merge. Rivers will reroute toward the deepening trough. And one day, perhaps 100 million years from now, the waters of the Gulf of Mexico or the Pacific might find their way in, flooding the interior and creating a new ocean, the Neo-Rio Sea. The thought feels alien, a sea in the middle of what is now the American Southwest, but geologically it's ordinary. That's how continents breathe. When stress builds up from within, the crust relieves itself by stretching. Mountains, once proud and immovable, become shorelines. Valleys, once dry, become seas. The Rockies, in their last act, may stand not as the center of a continent, but as its edge. Already, clues of this future are visible. In northern New Mexico, the Valles Caldera, a massive volcanic crater, hints at the kind of activity that accompanies continental rifting. Farther south, near Socorro, seismic studies have revealed a growing magma body just a few kilometers below the surface, a reservoir that may one day fuel the kind of eruptions that split continents. Even now, minor earthquakes ripple through the region, silent rehearsals for a drama that won't fully unfold for tens of millions of years. It's humbling to think that the Earth's next great ocean may be forming in our own backyard. Humbling and a little terrifying. But while geologists see in this the natural continuity of plate tectonics, philosophers see something else. a mirror for our own impermanence. The Rockies, those symbols of endurance, are destined to vanish. The land we call home will fracture, drift, and transform beyond recognition. Our civilization will be a thin stratum of dust, a chemical afterimage in the sediment of a future seabed. And yet, in that cosmic melancholy lies a strange beauty, because even as the land dies, it lives again, just in a different form. The new ocean will bring new life. New reefs will grow in the shallows where Denver once stood. New mountains will rise at the edges of that sea, driven by the same mantle convection that destroyed the old ones. The Earth does not mourn its transformations, it celebrates them. In 2023, a team at the University of Oslo used supercomputer simulations to model Earth's next supercontinent. They called it Amasia, a projection of how Asia and the Americas might eventually collide near the Arctic Circle. In their model, North America drifts northwest, rotating slightly, while South America and Eurasia converge from opposite sides. The Pacific closes, the Atlantic shrinks, and the Rockies are folded into a new mountain belt, the next Himalayas, formed on the ruins of the old. It's an image that defies imagination. Our familiar world rearranged like continents on a chessboard, and yet, it's the same cycle the Rockies themselves were born from. Every peak we see today was once an ocean floor. Every ocean floor will one day rise as a peak. That's the eternal symmetry of the planet, creation and destruction as two sides of the same process. And perhaps that's the real lesson the Rockies offer. Not permanence, but participation. They remind us that we are part of something vast. A process so immense that our lifetimes barely register, yet intimate enough to shape the ground beneath our feet. To know that the continent will one day split is not a warning. It's an invitation to see ourselves not as owners of the Earth, but as guests in its ongoing story. From the summit of Long's Peak at dawn, you can see the curvature of the planet stretching away, the shadow of the Rockies reaching across the plains like an ancient memory. The air is thin, the world silent, and in that silence, the mountain seems to hum, a vibration too deep to hear, too old to measure. It's the sound of tension building, of stone remembering its destiny. 100 million years from now, that hum may become a crack, that crack a rift, that rift an ocean. And the waves that wash against the shores of that new sea will whisper the same story we tell today, that nothing on this world is permanent. That even mountains must learn to move. Part 11, When the Mountains Fade, the Human Age and the Geologic Clock. In the presence of mountains, time feels different. Hours stretch thinner, minutes lose their urgency, and the weight of human history seems to dissolve into the air. Perhaps that's why people have always come to the Rockies seeking perspective, to measure the smallness of their lives against something that doesn't care about them. But what if even the mountains themselves are brief? What if the Rocky Mountains, those monuments of permanence, are, in the scale of the Earth, no more lasting than the civilizations built at their feet? To the planet, our entire history, from the first spark of fire to the roar of rockets, is the blink of an eye. The Rockies have seen ice ages come and go, seas rise and vanish, forests burn and regrow. And yet, when the first humans set foot in North America, these mountains were already ancient beyond comprehension. They had been rising, eroding, and rising again for 70 million years. To them, we are a rumor carried on the wind. Still, it is our instinct to measure them in human terms, to call them eternal, sacred, immortal. We name peaks after heroes, carve tunnels through their flanks, build cities at their base, believing that our monuments will endure as theirs have. But the geologic clock doesn't measure in centuries. Ticks in cataclysms. If the entire history of the Earth were compressed into a single calendar year, the Rockies would appear sometime in late November. Humanity would arrive a few seconds before midnight on December 31st. And everything we've ever built, every kingdom, every tower, every data signal crossing the planet, would vanish before the clock struck 12. The mountain endures longer than we do, yes, but even mountains fade. In another 50 million years, the highest peaks of Colorado may be nothing more than low, rounded hills, their granite hearts exposed to the wind, their snowcaps melted, their glaciers gone. Rivers will have eaten into their spines. The plains will creep westward. The ocean may rise to meet them. The Rockies will die not in fire, but in silence, dissolving grain by grain into the same rivers they once gave birth to. And yet, their death will give life. The sediment that erodes from their flanks will settle into basins, harden into new stone, and someday rise again as another mountain range. The atoms that make up these peaks will not disappear, they will simply change allegiance. They will belong to the next world, as they once belonged to the sea. In this sense, the mountains are the truest teachers of humility. They do not promise eternity. They promise transformation. To live in their shadow is to learn that permanence is an illusion, that even the hardest granite yields to the patience of water and time. But humans are impatient creatures. We have measured our existence in decades, not millennia, and built our cities on landscapes that move far slower than we can perceive. The Rockies may seem stable, but to scientists watching closely, the land beneath them is shifting, rising, sinking, breathing. The human age, the Anthropocene, has accelerated that motion in ways nature never intended. When we mine their cores for minerals, we disturb the ancient equilibrium of pressure. When we burn the fuels buried beneath their slopes, we alter the atmosphere that carved them. The glaciers that once sculpted their peaks are retreating faster than ever before, some vanishing within a single lifetime. In Glacier National Park, the ice fields that took 10,000 years to form may be gone within 20 more. Our impact is not measured in earthquakes, but in chemistry, in the invisible drift of carbon through air and water. And the mountains feel it. In 2019, a team from the University of Alberta measured the isotopic signatures of snow in the Canadian Rockies. They found traces of black carbon, soot from distant wildfires and human industry, embedded in the snowpack thousands of meters above sea level. Even at the roof of the continent, the fingerprint of our species is visible. We have marked the mountains with our breath. Geologists of the far future, if such beings exist, will find our presence not in bones or buildings, but in the rock itself. A thin, dark line of plastics, metals, and radioactive isotopes will mark the boundary between the Pleistocene and the Anthropocene. A layer so sharp it will be visible from orbit, if orbit still exists. They will know us by the suddenness of that line, by how fast everything changed. Perhaps they'll marvel at our ambition, a species that tried to understand the forces that shaped it. Perhaps they'll pity our arrogance, a species that mistook dominance for permanence. And yet, it would be unfair to see humanity only as a scar. After all, we are part of the same story. The mountains made us. They shaped the climate that allowed our ancestors to survive, the rivers that gave us water, the minerals that built our tools. The very iron in our blood and calcium in our bones once drifted through ancient seas, then crystallized in mountain rock. We are, quite literally, made of the Rockies. Maybe that's why we are drawn to them, why people climb them, paint them, photograph them endlessly. It isn't just awe, it's recognition. We are staring into the mirror of our own origin. But if we listen closely, the mountains whisper something else, not just about the past, but about the balance we are losing. The more we pull from the earth, the more the earth will pull back. The mantle beneath the Rockies has always responded to imbalance. It rises where the crust is lightened, it shifts where stress builds. Our civilization adds its own kind of weight, chemical, thermal, gravitational. The crust will respond in kind. The geologic clock is patient, but it never stops ticking. And yet, there's another way to read this story. Not as tragedy, but as perspective. To know that the Rockies will vanish one day is not to despair, but to see clearly. Everything we build, every system we create, every story we tell, they are temporary, yes, but also meaningful within their moment. The mountain does not mourn the river that carves it. It simply allows itself to be changed. Perhaps that is the lesson the earth has been teaching since long before we learned to listen. That meaning is not found in lasting forever, but in participating fully while we can. When we stand on a summit, wind howling, lungs burning, the world spread out below, we feel both infinite and insignificant at once. That paradox is the closest thing to truth we have. The mountains humble us not because they last longer, but because they remind us how fleeting we are and how beautiful that fleetingness can be. 100 generations from now, our names will be gone. The cities will be dust. The Rockies will be smaller, their outlines softened, their edges blurred by time. But the atoms that make us, the carbon, the calcium, the iron, will still be here, folded into the same slow cycle of uplift and erosion. We will rise again, as rain or rock or life. And the mountains, in some future form, will whisper to the sky once more, not of power, not of permanence, but of participation, because nothing truly ends, not even us. Everything just changes shape. Part 12, The Awakening Earth, When the Planet Speaks Again. There are moments when the Earth feels almost conscious, when its movements seem less like blind physics and more like the slow gestures of a living thing. You sense it in earthquakes that roll like a sigh through the crust, in volcanic plumes that bloom like breath, in the way magnetic fields shimmer and pulse around the poles as though the planet were thinking. And if the Earth were alive, if it could speak, then the Rocky Mountains would be its voice. A deep, resonant tone echoing through the stone, ancient but not silent. For millions of years, that voice has murmured beneath our feet, in the shifting of faults, in the rise and fall of land, in the long patience of erosion. We rarely hear it because we move too fast. But it's there, constant, humming through the crust like a heartbeat in the dark. Recently, scientists have begun to listen. Literally. Across the Rockies, networks of ultrasensitive seismic sensors record vibrations smaller than a single atom. They capture the tremors of rivers as they carve valleys, the footsteps of elk crossing frozen ridges, the faint thermal expansions of rock in the morning sun. When those sounds are sped up, something extraordinary emerges, a symphony of movement. It's as if the mountain range itself is breathing, murmuring, dreaming. This isn't poetry, it's data. Every mountain has a unique seismic voiceprint, a spectral signature that reveals its structure, temperature, and stress. And when these signals are layered together, a pattern appears. A rhythmic pulse, roughly every 26 seconds, recorded across multiple continents. No one fully understands it. Some say it's the resonance of waves crashing in the Atlantic, others claim it's caused by microquakes deep within the mantle. But a few geophysicists have suggested something more profound, that it could be the planet's global frequency, a kind of baseline vibration that links every part of the crust in a single harmonic. If that's true, then the Rockies are one of the great amplifiers of that resonance, a tuning fork for the Earth's internal music. When lightning strikes a ridge, when glaciers crack, when magma stirs far below, those signals join the chorus. Each one travels through stone, reflected and refracted until it becomes part of the planet's hum. The Earth, it seems, does speak. We just haven't learned to translate its language yet. But some people are listening differently. In recent years, artists, philosophers, and indigenous knowledge keepers have begun collaborating with geophysicists, creating what they call Earth resonance mapping, a fusion of science and sound meant to capture the voice of the living land. In one experiment in Banff, a team placed seismometers beneath alpine meadows and translated the data into audible frequencies. The result was haunting. A low, rolling tone punctuated by delicate pops and sighs, the acoustic fingerprint of the Rockies themselves. When they played the sound to elders from the Stony Nakota Nation, one said quietly, "That is the mountain remembering." It's a poetic phrase, but it carries a truth that even science is starting to recognize. The Earth does have memory, keeps records not just in rocks but in vibration, in how it responds to stress, in how its internal patterns shift after each quake or eruption. When the Rockies tremble, they're not just reacting, they're remembering the forces that shaped them. Some researchers now believe that by studying these deep resonances, we can predict not only future earthquakes, but long-term climate and crustal cycles, as though decoding the Earth's own subconscious. In a way, it's as if the planet is waking up to our presence, or rather, we are finally waking up to it. For centuries, we imagined the Earth as inert, a ball of rock and water we could mine, pave, and shape at will. Now, the evidence points to something much more complex. A system of feedback so intricate it borders on sentience. The biosphere, atmosphere, and lithosphere aren't separate. They're organs of a single body. The Rockies are its spine. The oceans are its blood. The storms are its nervous impulses. And we, with all our noise, our combustion, our cities, have become part of that body's activity, for better or worse. The question is, what happens when that body begins to react? Already, the signs are there, signals of imbalance. The permafrost is thawing, releasing gases trapped since the Ice Age. The ocean currents are shifting, altering the planet's heat distribution. The crust beneath Greenland and Alaska is rising as ice weight vanishes, releasing stored tectonic stress. Even the magnetic field, which shields all life from solar radiation, has begun to wander unpredictably. These are not random events. They are symptoms. The planet is rebalancing itself, responding to what we have done. If the Earth truly has a voice, then right now it is whispering, perhaps even warning. I remember what stability feels like, and you have changed the rhythm. To many, that sounds like mysticism. But to those who study planetary systems, it's physics. The feedback loops we've triggered are ancient, powerful, and self-correcting. They may not care whether we survive their correction. Still, there is something awe-inspiring in that realization, that we are alive during a time when the Earth is speaking louder than ever, and we have the tools to finally hear it. Satellites orbiting overhead monitor the flexing of the crust to within millimeters. Seismic networks record the tremors of mountains in real time. AI models sift through the noise to detect patterns humans miss. Pulses, harmonics, resonances that reveal the deep communication of the living planet. Perhaps, in a strange way, this is the beginning of dialogue. For the first time, we can listen to our world instead of simply extracting from it. We can hear the slow heartbeat beneath the Rockies, the deep sigh of glaciers melting, the whisper of magma rising like blood in a vein. We can understand the language of balance and maybe, just maybe, learn to speak it again. If that's not consciousness, then it is at least communion. Standing on the continental divide, where every drop of water must choose between east and west, you can feel that choice mirrored in yourself. The air trembles faintly, the ground hums beneath your boots, and for a moment, a heartbeat. It feels like the mountain is aware of you, not as an intruder, not as an enemy, but as a part of itself. It's a moment of recognition, fleeting but real. The awakening earth, speaking not through words but through resonance, reminding us that we were never separate to begin with, because the truth, whispered through stone and wind, is simple. We are not standing on the earth. We are standing within it. And when it breathes, so do we. Part 13, The Memory of Stone. How the Rockies Will Outlive Time. In the end, all that remains is silence. Not the silence of absence, but the silence of completion. The deep, resonant quiet that follows after something vast has spoken. That is the silence of the Rockies. They have said everything they needed to say. In stone, in snow, in the slow bending of light at dusk. And yet, even silence has memory. Long after the last glacier melts, long after our cities fade to dust and our satellites fall from orbit, the mountains will still remember. Their memory won't be written in words, or even in shape, because shape erodes, but in composition. In the atoms that once pulsed in the Earth's mantle, cooled, fractured, and rose into the sunlight. Those atoms are the archives of existence. Each grain of quartz in a Rocky Mountain boulder has lived many lives. Once it was part of the ocean floor. Before that, a plume of molten magma. Before that, a cloud of cosmic dust drifting between the stars. The rock beneath your feet, in other words, is older than the sun. The mountains are not the beginning of a story, they are one of its continuations. When we touch them, we touch the universe remembering itself. That is the strange, humbling paradox of geology. The longer you study time, the less you believe in endings. Every mountain that dies gives birth to another. Every erosion is an act of renewal. The Rockies may one day flatten into a plain, but the matter that made them will never vanish. It will simply migrate, recombine, reform. Perhaps in another galaxy, those same atoms will gather again, swirling around a newborn star. Maybe that's what eternity truly means. Not unchanging stillness, but infinite transformation. In that sense, the Rockies are not monuments, they are verbs. They are the earth in the act of remembering itself. You can see this in the details. The way riverbeds sparkle with the ghosts of glaciers. The way fossils press against sandstone like fingerprints from another world. Each layer of rock is a page, each mineral vein a sentence. And across those pages runs one consistent theme: continuity. Even the decay of the mountains serves a purpose. Their erosion feeds the plains, fertilizes the oceans, balances the carbon cycle. Without their slow dying, life could not persist. Their death is our breath. When you step back far enough, when you strip away the illusion of scale, you realize the Rockies are not separate from life. They are life slowed down, the planet's metabolism in mineral form. That's why ancient peoples called them sacred. They didn't need seismographs or satellites to feel the continuity. They knew intuitively that mountains were more than stone. They were memory, stability, identity, a conversation between heaven and earth. Even today, if you listen at dawn, before the wind rises, you can almost hear it. The deep, slow pulse of existence moving through the valleys, echoing through your ribs. It's not imagination, it's resonance. The same vibration that shapes mountains also shapes us. Modern physics confirms what mystics have always whispered. Everything vibrates. Atoms are not solid things, but rhythms of energy, standing waves in an ocean of spacetime. The mountain and the human differ only in frequency. One hums low and patient, the other burns fast and brief. But both are part of the same song. So when the last snow melts, when the last peak crumbles, the song will not stop. It will simply shift key. That is the real memory of stone. And if consciousness has any cosmic purpose, perhaps it is this: to be the mountain thinking about itself. To give the universe a way to look inward. Through us, the Rockies remember that they are alive. Through them, we remember that we are temporary. The awareness passes back and forth like sunlight over a ridge. Fleeting, but enough. We are the breath between two geological epochs. And that's enough. When future beings, whoever or whatever they are, walk upon what remains of North America, they may find no trace of Denver or Calgary or Yellowstone. But they will find the imprint of our presence, faint but distinct. A thin band of altered minerals, a residue of carbon and iron, a silence where once there was industry. They will see that something here once burned brightly and briefly, a civilization of noise that was, for a moment, self-aware. And maybe, if their science has a poetry of its own, they'll understand what we finally began to learn at the end. That the earth was not our possession but our partner. That the mountains were not obstacles but mirrors. That we were not above them, we were within them. Even now, as satellites watch the Rockies from orbit, their outlines glow faintly under starlight, a jagged pulse against the curve of the planet. From that height, they look small. But to the mantle below, they are titanic scars, still reshaping the flow of magma, still influencing the pattern of clouds and rivers. From both directions, above and below, the mountains define the edge of awareness. If the Earth ever achieves true self-recognition, if the sum of its systems ever coheres into something that could be called thought, the Rockies will be part of that awakening, synapses of stone in a planetary brain. Their peaks will store the memory of motion, their roots the memory of heat. The crust will be the circuitry of existence itself. And perhaps, in some distant epoch, the Earth will open its eyes, not in language, not in mind, but in equilibrium, and realize what it has always known. That creation and decay are the same event, seen from different sides of time. Until then, the Rockies wait. They will outlive our calendars, our myths, our machines. They will rise and crumble, freeze and thaw, and someday become sand carried by alien winds. But through it all, they will keep the same rhythm, the same slow, patient pulse that began when the first mountains rose from the primordial sea. The rocks do not forget. They simply wait for someone new to listen, and when that listener arrives, whether it's a future species, an artificial mind, or the Earth itself, they will find, deep within the fossils and isotopes and silicate lattices, traces of us. Not as conquerors, not as caretakers, but as witnesses. The ones who heard the mountain speak, and for a fleeting moment, understood. So let this be the closing note in the Earth's long song, that everything that rises will one day fall, that everything that falls becomes the seed of rising, that memory is not about holding on, it's about becoming. The Rockies have always known that. Now perhaps so do we. Dawn comes softly to the Rockies. No trumpets, no applause, just a slow unfurling of light, touching each ridge as if the sun were relearning their names. The air trembles with cold, and for a moment, everything is still. Then the first gust of wind rises through the pines, and the world exhales. It is the same breath that has moved through these valleys for millions of years, older than language, older than thought, older even than memory. Standing there, you realize that everything that has ever lived on this planet has shared that same breath. Dinosaurs, mammoths, eagles, humans, all borrowed from the same invisible current that drifts now across the peaks. It is the most democratic thing in the universe, air. Unowned, unending, shared. The Rockies taught that long before we knew how to listen. They taught patience in the slowness of stone. They taught humility in the way rivers carve through granite without anger or haste. They taught endurance not as resistance but as acceptance of change. And above all, they taught that nothing is separate, that the human heart and the mountain's core beat in the same rhythm, just at different tempos. We have tried, for so long, to stand apart, to see the world as something to conquer, to name, to measure. But when the wind crosses the peaks and you feel it against your skin, there's no distinction anymore. You are part of the same circulation. You are a temporary shape in the same ancient pattern. Someday that pattern will move on without us. The cities will crumble. The roads will fade beneath lichen and dust. Satellites will fall like rain. And the Rockies, diminished but still breathing, will watch as the world rearranges itself once again. Perhaps new continents will rise. Perhaps the atmosphere will thicken or thin. Perhaps the planet will go quiet for a while, letting time reset the tempo. But none of it will be loss, just transformation. Because memory is not about what remains. It's about what continues. The atoms that once sang as wind through aspen leaves will one day hum in the tail of a comet. The minerals that formed the Rockies' spine will dissolve into ocean sediment, then harden into new peaks. Even the light bouncing off these slopes right now will travel into the cold dark, perhaps to be seen again by an eye we'll never know. We are temporary witnesses in an infinite story. And maybe, just maybe, that's enough. Because to have existed here, even briefly, is to have been part of something vast and self-aware. To stand on a mountain is to stand inside the universe's memory of itself. It doesn't matter that we'll vanish. The universe remembers through transformation. The Rockies remember through erosion. And the Earth remembers through us, through the minds that saw and wondered and gave names to the nameless. Perhaps that's what it means to be human. Not to dominate the world, but to notice it. To translate the mountain's silence into meaning, even for a moment. The last light fades now. The horizon turns to fire, then to ash. Shadows crawl up the peaks, soft and slow, until the land becomes one continuous breath again. Mountain, cloud, sky, indistinguishable. And somewhere in that merging, the Earth speaks one last time. Not in words, not in thunder, but in stillness. Remember me not for what I gave, but for what you became while you were here. It's not a warning. It's not forgiveness. It's acknowledgement. Because everything that was ever alive, every whisper, every stone, every dream, is still here, folded into the memory of the planet. We were here. We were part of the pulse. And though our time was short, we left a sound that still echoes through the crust, through the air, through the light. It's faint now, almost lost to the hum of deeper things. But if you listen closely on some quiet dawn in the Rockies, you might still hear it. The sound of humanity, a single breath, shared with the earth, forever.